Good morning, students. In the last video sessions, we started with fourth unit with regarding to sorting techniques. We have discussed with insertion sort mechanism and three types of insertion sorts. That is simple insertion sort, linked insertion, and then binary insertion sort mechanism. So what we are doing with insertion sort mechanism is, in the insertion sort mechanism we are in the insertion sort mechanism we are taking a value, that is we are taking an element from an array, and moving it to the sorted position. So taking an element from an array and moving it to sorted position, and then shuffling the elements, moving it to sorted position and then shuffling the elements to make the array sorted. This is what we are doing in the insertion sort mechanism. It may be with array insertion, it may be with linked insertion, it may be with binary insertion. So what we are doing with insertion sort is taking an element from an array, moving it to a sorted position and then shuffling of the elements. So here what happening in the insertion sort is, each and every time we are taking a value and then we are finding a proper position for it and then we are shuffling the elements. So which is where the complexity is, where when compared to time complexity is higher when compared to the other sorting algorithms because of this process. So in order to avoid that, what we are having the better sorting technique, the better sorting technique when compared to insertion sort is, that is straight selection sort is also a similar to insertion sort, but which provides somewhat more flexibility, that is it reduces the time complexity when comparing to the insertion sort. Now what we are doing in the selection sort is, the smallest value among the elements in an array, the smallest value will be moved to the first position. That is what we will be making the elements in the sorted order. In a selection sort, the smallest value among unselected elements of the array. Unselected elements means that is the smallest value in an array is selected and it will be made into a proper position and it will be inserted into its appropriate position, as similar to insertion sort. The same what we are telling with the insertion sort, the same thing we are taking here. The smallest value will be moved to its appropriate position, making the array in a sorted manner. So what we need to do in the selection sort is, first we need to find the smallest value in an array and we need to place it in the first position. How we are placing it in the first position is, we are not shuffling the elements. What we are doing is, here is we will be swapping the elements. So in the first what we are doing, find the smallest value in an array. So we will search for the smallest value in the array, we will take a smallest value in the array and then place it in the first position. That is whatever, if the smallest value is in last position, we will swap the last position and first position. Whereas in insertion sort, what happens is, if the smallest value is in the last position, we will shift it to the first position and then the remaining all the elements are shuffled to the next locations. So hope you are understanding the difference to insertion sort and selection sort. In the insertion sort mechanism, we are taking a value, moving it to appropriate position and shifting all the remaining values. But with the selection sort, we are taking a smallest value in the array and then placing it in the first position. And then again what we do, in the second pass, we take the second smallest value, place it in the second position. Third pass, take the third smallest value, place it in the third place. Take the fourth smallest value, place it in the fourth place. That is how we will be performing the selection sort. So the array with n elements is sorted by using n minus 1 pass of selection algorithms. That is, if you are having 5 elements in an algorithm, 5 elements in an array, now how many pass it takes is, it takes 4 passes. Pass 1, first smallest; pass 2, second smallest; pass 3, third smallest; pass 4, fourth smallest. In pass 5, that is the sorted element. So we need to have 4 iterations. We need to perform 4 iterations to make the array in a sorted array. That is, if we are having n elements, how many iterations we need is, we need n minus 1 iterations to make the array in a sorted order. So the complexity is similar to the insertion sort. Whatever the complexity we are representing, the complexity is similar to insertion sort. But what the difference is, the performance, the steps in the steps that are used in performing sorting technique, those that differs here. In insertion sort mechanism, we need to insert the value in its appropriate position and we need to shuffle. Now here we are selecting a value and then swapping it with the, and then we are swapping the positions. That is what we are doing here. See, suppose I am having elements like this, 10, 2, 3, 90, 40, 356. Now among those, 2 is the smallest value. Among all these values, 2 is the smallest value. Now what I am doing is I am swapping 2 with the first location. So that 2, 10, 3, 90, 43, 56. In the second pass, what I am doing, I am taking the second smallest value, it is 3, and swapping it with the second element. So 3 3 is the second smallest value. It has to come to the second position. So 3 and 10, swap 2, 3, 10. Like this we will be swapping all the elements. Similarly, like this we will be swapping all the elements in the array. Now coming, so now what happens in pass 3, we will selecting the third smallest value, moving it to the third position. Pass 4, selecting the fourth smallest value and then moving it to the fourth position. In pass 5, this is the smallest value such that it remains in the same location. So coming to the complexity. So what the complexity we are having with the insertion sort, the same complexity with the selection sort. Now coming to the algorithm. Now we go with the algorithm. What we need to do? We need to perform repeat the steps. What we are doing is we have to repeat the steps 2 and 3 for k equals to 0 to n. That is for as array starts from 0 to n, 6 values, 0, 1, 2, 3, 4, 5. So for 6 values we will be representing. So first what we need to find, we need to find the smallest value. For that I am taking a function called smallest to find the smallest value in the array. Next what I am doing is I am taking, after finding the smallest value, what I am doing, I am swapping the value of ak with the array position. What is the smallest value I am having, with which position I am acquiring the smallest value, I will take that position. That position value will be swapped with a0. K starts from 0. 0 is the first location. POS is the value. POS contains the value which contains the sorted value. POS is nothing but the position in the array which contains smallest value that we will be getting from this algorithm, smallest algorithm. Now what we are finding here, set small equals to array of 0. Taking a 0 n value, that is the size of the array, and then set small equals to array of 0. The first we are making, we are assuming ourselves the first location value is the smallest value. And now POS, as it is the smallest, we are taking the position 0 as the smallest. Now what we are doing here, so remaining, so now we are assuming first location is the smallest. Now what we need to do, we need to compare from first location to n locations, that is with the first location to n minus 1 locations, to find is there any other small value other than a0, such that taking loop j equals to k plus 1 to n to find the smallest value. See condition here, if small greater than array of j, small is array of 0, so array of j is 1. If it's small greater than array of j, like that, what happens in this algorithm is it finds the smallest value. Whenever we obtain a smallest value, immediately what we are doing is we are taking that location into the position and we are returning the position. So I am keeping this algorithm side, we will explain it with the help of an example. As similar, taking that algorithm, we will be explaining it with an algorithm. So what we need to do first, this is an array with the 5 elements 50, 40, 30, 20, 10, n equals to 5. Now what we are doing here, first we need to find the smallest value, smallest array, k starts with 0, n equals to 5. So first what we are doing, we are assuming a0 location as the smallest, small equals to a of k, array of kn. So small equals to 50. First we are assuming 50 as the smallest value. Now we compare from now we take another loop starting from first location, comparing it with the smallest value. So what we are doing, j equals to 1, j equals to 1 to 5, 1 to n, j equals to 1 to n. We compare the value of aj, that is small. What we are written here, what is the condition here? If small greater than array of j, that is the condition. If small greater than array of j, small greater than array of 1. What is small here? Small is 50, 50 greater than 40. So condition true. If the condition is true, what we are doing here, this is the smallest value. 50 greater than 40 is condition true. That means 50 is not small. So 50 greater than 40, condition true, 40 is the smallest. So we are making small equals to 40. When we obtain the smallest value, what we are doing is we are taking the j value into position and we are returning the position. Return position. So what we are doing is we will returning the position. So when we return the position is after completion of one pass. Here we are checking with a of 1. So small equals to 40, position equals to 1. Again we repeat the loop to find is there any other smaller element other than 40, is there any other smaller element. So when j moves to 2, now small is 40, array of 2, 40 greater than, what is array of 2? 30. This is condition true. Now again small becomes 30. Now again we repeat j to 3. Now what happens here? J becomes 3. Now the small is 30, 30 greater than 20, condition true. Again we repeat the loop. So j becomes 4. So for now the small is 20. Now the small is 20. What is the value in fourth location is 20 greater than 10, which is condition true. Now small becomes 10 and the position becomes 4. Position equals to j. Now j plus 5, 5 less than 5 condition becomes false. Now what is the position? 4. We return that position. So now what we are doing here, we will returning that position. Now after the first pass, when I equals to, when we are starting with I equals to 1, repeat for k equals to 0 to n. We are starting with repeat for k equals to 0 to n. For k equals to 0, POS equals to 4, which contains the smallest value. So that what we are doing is we are changing a of k value with a of POS. So we are shuffling these values such that what happens now after first pass, now k becomes 0th location will be occupied with 10, remaining all locations will be same, 40, 30, 20, 50. This is how the array will get sorted. Similarly, when k equals to 1, again the loop starts for j equals to 0 to n. Now what is k here? K is 1 here. Now we are starting from 1. So small equals to array of k 1 to 5, j equals to 1 to 5. Repeat for j equals to k plus 1 to n. K plus 1, as we are taking k, that is starting now k equals to 1. A of k, set small equals to a of k, that is now small equals to 40. Now what we need to do? We need to check from second location. We are taking from second location for j equals to k plus 1. K plus 1, that is for j equals to 2 less than 5. Now we compare. What is the 2? 2 is 20. Small is 40. Sorry, 0, 1, 2. Now we start with second location. Small greater than 30. Condition true. As condition true, small, what is small? 40. 40 greater than 30. Condition true. Now small becomes 30. Again we repeat the loop. J becomes 3. Again we repeat the loop. J becomes 3. 3 less than 5. Condition true. Now what is the value in third location? 20. 30 greater than 20. That is small. This is a small here. Small is 30 now. 30 greater than 20. Condition true. Now small becomes 20 and j becomes 4. Now 4 less than 5. Condition true. So what is the value in fourth location? 50. So now 20 greater than 50, condition false. So now condition false. What is the, from where the small value lies? The small value lies only in the third position. Here the POS stops with 3. POS equals to 3. So we return this POS, and then now what happens is, now in this the POS will be sorted with the first value. K equals to 1. At K equals to 1, here now A of K equals to A of POS, K equals to 1. A of location is sorted with A of 3. Now instead of 40 it gets 20, and instead of 20 here it gets 40. Likewise, remaining all the process will be performed, making the selection sort mechanism. This is how we will be performing the selection sort. Next to the selection sort, what is the other sorting technique we have been having is, we will be having the heap sort mechanism. So this is a heap sort mechanism. We already discussed with a heap sort mechanism. We already discussed with a heap sort mechanism when we are discussing with heap trees. You know what heap tree is? Arranging the elements in the form of minimum heap and maximum heap. Whenever we are representing a heap trees, we represented two types, that is minimum heap tree and maximum heap tree. A minimum heap tree is one where the root node is the smallest. Minimum heap tree, root node will be smallest value. Maximum heap tree, the root node will be the smallest. So minimum heap tree or maximum heap tree representing the order of an array. What this heap sort algorithm is, arranging the elements in a tree structure. In a tree structure, we need to arrange the elements in a, either in a minimum heap tree or in a maximum heap tree. Root node is the smaller to all the elements, that is minimum heap tree. Root node is maximum to all the elements, that is the minimum heap tree, that is the maximum heap tree. If the root node is smallest value, it is minimum heap tree. If the root node is largest value, that is the maximum heap tree. So now what the heap sort algorithm is, it is a recursive process to maintain two operations. What we need to do, we need to build a heap using the elements of the array. We are having some elements in the array. Using those elements, we will be making a heap tree. Now repeatedly delete the root element of the heap formed in phase 1. What we are doing, we will be deleting the root node. So we will be deleting the root and making the tree into a sorted position. So why we are making is, we, in order to make it into a minimum heap tree or a maximum heap tree, we will be deleting the root and arranging remaining all the nodes into a sorted order. This is what we are building. This is what we have been representing with the heap algorithm. So first we need to build a heap tree. So for I equals to 0 to n minus 1, taking values of an array, we will be building a heap tree called insertion of heap, and then which we have been building the heap tree. After building heap tree, we are deleting the root node. So we will be deleting the root node until we reach to the 0. So while deleting, what we are doing with the deletion is, we will be performing these steps with the deletion. So how we are implementing the heap sort? First we are taking the largest element, root, as the largest element. To the left of the root, 2 into I plus 1, and right 2 into I plus 2. So what are the values we are having in the array position? 0, 1, 2, 3. So 0th value is considered to be root. Now which value should come to the left of the root? Which value should come to the right of the root? The values with 2 into I plus 1. Suppose the first location value, suppose array having, suppose consider these, this is an array 4, 10, 3, 5, 1. This is an array where the elements in unsorted array. Now what we are doing here is, first we need to construct the heap tree. How we are constructing the heap tree for these array elements? Taking this as the root element. This is equals to I. So first suppose we are assuming the first location as the root element 0. This is the root. 0th location as taking as the root. Now to the left, what should be the left child? 2 into I plus 1 must be the left child. 2 into I plus 1. I is 0. 2 into I plus 1. 2 into 0 plus 1. 2 into 0, 0. 0 plus 1, 1. What is the value in first location? That becomes the left child. Now similarly right child 2 into I plus 2. So I 0, 2 into 0, 0, 0 plus 2. What is the value in second location? That becomes the right child. Now 5. So 5 is the third location. Third location means 5 has to come either to the child of 10 or either to the child of the 3. Now taking this as the root now. This is the root 2 into I plus 1. What is the I now? I1. That is I is the first location value. So I1 2 into I. 2 into I is 1. 2 into 1 2. 2 plus 1 3. Is there value in third location? Yes, the value in third location is 5. That comes to the left of the 10. Similarly 2 into I plus 1. 2 into I plus 1. 2 into I 1. So 2 into 1 2. 2 plus 1 3. The value in third location becomes to the left. Now coming to the right 2 into I. What is the I now? I is 1. 2 into I 2. I is 1. So 2 into 1 2. 2 plus 2 4. Is there value in fourth location? Yes, 1. That becomes right child to 10. Similarly, if I am having any fifth value 2 into 2 plus 2. 2 into 2 plus 2. 2 into 2 4. 4 plus 2 6. That becomes right. 4 plus 2 6. That becomes right of this tree. So likewise we will be constructing. Suppose if I am having a value with a 5. 5 means where it has to come? 2 into 2. 2 into this. There it will come for this. 2 into 2 into 1. 2 into 3 6. 6 plus 1. 2 into 4 8. This is the location. 2 into 2 plus 1. For this this is the third location value. For this value 2 into 2 plus 1. If I am having 5 6 2 into 2 4. 4 plus 1 5. For this location if I am having fifth, for the 3 it comes as the left. If I am having 6 it comes as the right. Like this we will be representing. So this is an unsorted array made into an heap tree structure. Now in order to sort the elements, what we are doing is, in order to make this heap tree into a sorted notation, we have to delete the root. So now this deletion process, how we are deleting, how we are performing the heap sort mechanism. Take the largest element as I. Whatever the largest element we are having in the array, take that, move that largest element to the root. That is, largest element to the root means we are constructing a maximum heap tree. If the root is largest, it is a maximum heap tree. So in a heap sort mechanism we can construct in two ways. One is a minimum heap tree and the other one is maximum heap tree. Now with what we are taking, set largest equals to I and ante among all the elements in a tree, find the largest element and make it as a root and move it to root location. So among all these elements, in an unsorted array, 10 is the largest element. We know how to find the largest element in the array. So now 10 is the largest element. So that is move to 0 location. Now after moving to 0 location, now we need to find the second largest element. What we need to do? We need to find the second largest element. What is the second largest element? The second largest element here is 5. The second largest element is 5. Now how to arrange these 5? See here, if left child is larger than root, or if left child is larger than root, largest equals to L. If right child is larger than root, then largest equals to L. If largest not equals to I, then swap array of I to array of largest. So this is the root 10. We are having 10. Next we are having the next largest value 5. We will be arranging the value 5 10. What is the next sorted value? Next largest value 5. Again take what is the next largest value. What is the next largest value among these 4? So find the next largest value 4. Next find the next largest value 3. Next find the next largest value 1. This will be the sorted array 10 5 4 3 1. Now in order to make them as the childs, follow these steps. Which should make a left child? If left child is larger than root element, array of left greater than array of largest, then make it as the largest element. If the right child is larger than root, then make it as largest equals to R. If at all not, use the above steps. Set largest equals to I, left equals to L, right equals to 2, and then perform this process. This is how we will be representing the heap sort mechanism. The next sorting mechanism is the bubble sort mechanism. So it is the simple and the very common sorting technique that is being used everywhere. Bubble sort mechanism is otherwise called as exchange sort mechanism. Up to here, with all these insertion sort, selection sort, heap sort, these are all one kind of sorting techniques. Bubble sort, quick sort, shell sort. These three are other kind of sorting techniques. Bubble sort, quick sort, shell sort, and then merge sort. These four are the other kind of sorting techniques. So what we are doing with bubble sort mechanism, value of A0 is compared with A1. A1 is compared with A2. A2 is compared with A3. A3 is compared with A4. A4 is compared with A5. Like this, for one pass, one particular value, the value will be moving to its last position. The value, one sorted value, finding one sorted value and moving it to its desired position. So the same process, the process is same wherever we are doing. In the insertion sort also, we are taking a value and moving it into the sorry, same, the process we are doing is the same with every sorting technique. We are taking value and moving it into a desired position. That is what we are performed with insertion sort. With insertion sort, we are taking a value, moving it to an sorted position, moving it to sorted position, and we are shuffling the values. See, that is the process there. What we are doing there is there. Suppose if I am having 5 values, suppose if I am having like values 50, 40, 30, 20, 10. Now what I am doing, 10 is the value which I need to place in the first location. So sorry, 10 is the value which I need to place in the first location. What I am doing is taking 10, directly swapping, moving it to first location, and then what I am doing is I am shifting the values. A0 value is shifted to A1, A1 is shifted to A2, A2 is shifted to A3, A3 is shifted to A4. So A4 is the smallest value. I am moving it to the first position, A0 position. Now what I am doing after moving to A0, the already existing value in A0, that is moved to A1, A1 is moved to A2, A2 is moved to A3, A3 is moved to A4. Coming to selection sort, what I am doing is same 50, 40, 30, 20, 10, 5 elements. So 10 is the value which moved to sorted position, A4, that is the least value. Now swapping it with A0. I am not shuffling here. What I am doing, A4 value, swapping it with A0 value, that is with selection sort. Now heap sort mechanism, what I am doing with heap sort mechanism is, in the heap sort mechanism, I am taking the largest value and making it as a root. Either it may be a maximum heap or a minimum heap. If it is a minimum heap, suppose 50, 40, 30, 20, 10. If I need to make a minimum heap tree, I will take 10 as a root. After 10, what is the smallest element? 20. That should come. So now what I am doing is, I am arranging the elements in the array order. So first smallest element 10, next smallest element. First I need to find all the smallest values. Make it into array. Make it into array. Now construct the heap tree based on the process of heap. That is 0 is the root, right is 2 into I, left is 2 into I plus 1, right is 2 into I plus 2, such that we will be framing a heap tree location. Okay, this is the process we have been representing here, where for wherever we have been taking list value and then moving it to appropriate position. So the same thing with the bubble sort, but what we are doing here, A0 comparing with A1, A1 with A2, A2 with A3, A3 with A4. Then 5 elements, taking example of 5 elements, A0 A1, A1 A2, A2 A3, A3 A4. Now the A4 will get a value in sorted position. Again I repeat the process, A0 to A1, A1 to A2, A2 to A3. Now A3 will get the sorted value. Again I repeat the process, A0 to A1, A1 to A2. A2 will get a sorted value. Again the process A0, A1, A1 will get sorted. Now again A0 remains in sorted position. Here what we are doing is we are exchanging the values. Exchanging the value of A0 to A1, A1 to A2, A2 to A3, A3 to A4. That is what we call as the exchange sort mechanism. These are called exchange sort mechanism. See, A0 is compared with A1, A1 with A2, A2 with A3. Like this we will be performed. At the end of pass 1, one value. If it is ascending order, the largest element will come to the end position. If it is descending order, the smallest value will come to the last position. So what we are doing is we are taking values from 0 to n minus I minus 1. So what we need to, how we need to compare? We need to compare A0 with A1, A1 with A2, A2 with A3. That is the process is, this is the process. A0 value is compared with A1 value. So swapping those two values. If it is greater, swap those values. Like this will be performed. So here a small example here, taking see now 3, 4, 1, 2, 5 are the values I am having. Now I need to swap the values, taking with starting with 0, A0. So A0, j equals to 0 to n minus I minus 1. So swapping A0 value with A4, 3 greater than 4, false, there will be no swapping. 4 greater than 1, A1, A2, swapping, these two will be swapped. Again 4 greater than 2, swapping, these two will get swapped. Again 4 greater than 5, no swapping. Here the 4 remains. Now how will be the array after this pass? 3, 1, 2, 4, 5. Now again we take, this is pass 0, this is pass 1, again for pass 2. That is when I equals to 0, when I equals to 1, when I equals to 2. So now what happens here? So 3 greater than 1, condition true, swap. So 1 and 3 will get swapped. Again, now this 3 greater than 2, condition true, swap. Now 3 greater than 4, false. So after this pass, 1, 2, 3, 4, 5. As we have taken the elements in such a notation, we will be getting the values in the sorted order. This is how we will be performing the bubble sort mechanism. So students, we have discussed with 3 algorithms here. So probably today I will have a schedule for you. Today or tomorrow we can have a schedule discussing about these algorithms. So note down these algorithms into your notebook. So there will be, I hope there will be little bit confusing for you. I will be explaining, I will be scheduling the classes either today evening or tomorrow. So please note down these with your notebooks while we are being so that it will be easy for our discussion. Thank you.